Good afternoon. Last lecture we have seen the conditional probability and independence, and we have seen the definition of independence of two events, and we have solved the numerical example on independence of two events. And in this lecture we have give the another example of independence of two events. That is, example is consider the experiment of rolling a pair of die. That is, here the sample space of rolling a pair of die is ohm equal to 1 2 3 4 5 6, and we have find the probability that is a is occurrence of an even number, that is in the total sample space. We have um, give the favorable outcomes, that is of an even number, and here even number is 2 4 6, and b b is the occurrence of a number less than 3. That is, here we have give the occurrence of a number less than 3, and here less than 3 number is only b equal to 1 2. Then we find the probability of event a intersection b. That is, we find the probability of event a, that is equal to m by n. M is the favorable event is 3, and divide total sample space here is 6, that is 3 by 6 equal to 1 by 2. And second, probability of event b is the occurrence of a number less than 3, and here m by n, m is the favorable event is only b equal to 1 or 2, that is 2, m equal to 2 divided by 6. 6 is the total sample space, that is n equal to 6, 2 by 6 equal to 1 by 3. And then we have find the event probability of event a intersection b equal to probability that is, we find the first a intersection b, that is here a equal to 2 4 6 and b equal to 1 2, and here a and b is the intersection a and b only 2, that is the probability of event 2, that is probability of event a intersection b equal to probability of 2. That is equal to m by n. We find the first probability of event a is that is probability of 2, that is m by n. M is the favorable event, here only a intersection b equal to favorable event is 2, it is 1, and total sample space is 6, that is probability of event a is 1 by 6, and probability of event b equal to 1 by 6, and therefore probability of event a intersection b equal to probability of 2 equal to 1 by 6 equal to probability of a into probability of b. And by definition, here we have proved a and b are independent event. And then we have seen the another example. Consider the experiment of tossing three pairs pair coins simultaneously. Here we have tossed the three coins at the same time. That is, we have get the total sample space. Here is ohm equal to, that is, we have tossed the three coin, and we have give the total sample space. Here H that is head, and second sample space is head tail, head tail head tail head tail, and it tail head, and last is three coins is tail. That is, here we have tossed the three coin simultaneously, and we have get the 8 sample space, that is n equal to ohm equal to number of element in ohm in, that is n equal to n. And first we have let A equal to getting more than 2 heads. That is, here in total sample space more than 2 head is only favorable event is 1, that is head. That is A equal to H, that is head, and n of A equal to 1, that is favorable sample space is 1, where n of A equal to number of element in event A, and probability of event A equal to n by n divide n by ohm. That is, n by n is favorable event is equal to here only more than 2 heads, that is only one sample space. Favorable event is 1, that is head. A equal to n of A equal to only 1, and total sample space here of is 8, that is 1 by 8. And second, let B equal is the occurrence of a getting at least one tail. Here one tail is total sample space 1 2 3 4 5 6 7. At least one tail is, first is HHT, HTH, THH, HTT, THT, TTH, and last is TTT, that is tail. That is, here at least one tail equal to total sample space, that is favorable event is n of B equal to 7, where B equal to number of element in B, and we find the probability of event B equal to n by B equal to n of S. S is the total sample space. That is n by is the number of element in B equal to 7 divide 8, and therefore probability of A intersection B equal to 0, and here therefore probability of A intersection B is not equal to probability of A into probability of B, and therefore A and B are not independent. In this example, A and B are not independent. Here we have proved.